just give your attention here. This P1 V1 to the power gamma equal to PdV to the power gamma, that means PV to the power gamma equal to constant. That was the last topic I have discussed, adiabatic expression. Based on that, the next thing that we will do is here. PV to the power gamma equal to constant. If we differentiate both sides, constant, if you do the differentiation, what do you get? 0. If you do the differentiation of a constant, what do you get? 0. So now PV to the power gamma equal to constant. If you are doing differentiation both sides, we get this gamma P V to the power gamma minus 1 dV plus V to the power gamma dP equal to 0. Now we are dividing, doing the side change and dividing by V to the power gamma minus 1. So you get this relationship. You can try on your own. Do the practice right now. Take this equation, PV to the power gamma equal to constant. Write down PV to the power gamma equal to constant. Now do the differentiation both sides, and you get the relation, this particular one, this relationship. Gamma P V to the power gamma minus 1 dV plus V to the power gamma dP equal to 0. Because right hand side was constant, so differentiation will be 0. Next step, we divide both sides by V to the power gamma minus 1. So it will become gamma P dV plus V dP equal to 0, or V dP equal to gamma minus gamma P dV. If you do the same thing with PV equal to constant, isothermal process, you know PV equal to RT, suppose T constant, then RT equal to constant, so PV equal to constant. So for the isothermal process, PV equal to constant. Do the differentiation both sides. The same way, do the differentiation both sides. What do you get? VdP equal to minus PdV. Do it and find out. Take PV equal to RT and consider T constant as it is isothermal. Then what do you get? PV equal to constant. Now differentiate both sides and you get PV equal to nRT. Here T is taken, just see, PdV plus VdP equal to nRdt. So that way if you do the differentiation both sides. So this one, if I take similar way, if I take PV equal to RT, listen to me, write down. Just write down PV equal to RT and T constant for isothermal process. Then PV equal to constant. So PdV plus VdP equal to 0. PdV plus VdP equal to 0. So VdP equal to minus PdV. Write it down. VdP equal to minus PdV. And on the other hand, if you take adiabatic relationship, this is your final relation, VdP equal to minus gamma PdV. This is for adiabatic. And for isothermal, what is happening? VdP equal to minus PdV. So what is the difference? Gamma difference. For adiabatic, there is one extra term, that is gamma, which was not there in your isothermal. In case of isothermal, VdP equal to minus PdV. And for adiabatic, VdP equal to minus gamma PdV. So as a result, this gamma, suppose this one is the slope. If you take y equal to mx equation, make a plot, graphical plot for adiabatic plot and isothermal plot. How much will be the difference? Which one will be steeper? Which one will be steeper, you think? Adiabatic and isothermal? This is adiabatic and this is isothermal. Okay. If you make a plot, adiabatic and isothermal will be much more flatter and adiabatic will be steeper. Why? Mathematically I can prove that. As I told you, do it yourself. PV equal to RT equal to constant, because T constant, isothermal, no? So T constant. Then do the differentiation. PdV plus VdV equal to 0. So what is VdP? Minus PdV. Or not? Then for adiabatic, VdP is coming what? Minus gamma PdV. So what is additional factor? That is gamma. For adiabatic, there is a gamma terms compared to isothermal. And gamma is what? Always more than 1. What is the value of gamma? For monatomic 1.66, write down. Gamma values for monatomic 1.66, for diatomic 1.44, for triatomic 1.33, and so on. And normally molecules are monatomic, diatomic, triatomic, right? So I am not going for higher. So monatomic, diatomic, triatomic, always the values are more than 1. Monatomic 1.66, diatomic 1.44, triatomic 1.33. Now tell me one thing, these all values are more than 1 or not? These are all more than 1. So that means this gamma value at least to be more than 1. So adiabatic slope, this is the adiabatic slope. dPdV. What is the adiabatic slope? dPdV equal to minus gamma P by V. Minus gamma P by V. And what about isothermal? Minus P by V. No gamma there. That is the only difference. No gamma. Okay. For adiabatic, minus gamma P by V. dPdV equal to minus gamma P by V. And for isothermal, dPdV equal to minus P by V. No gamma. The difference is gamma. Gamma is more than 1. Always. That you have noted. That's why the adiabatic and isothermal, which one will be steeper? Adiabatic will be steeper because slope is higher. Higher slope is steeper. Lower slope is flatter. So adiabatic is steeper compared to isothermal. That plot I have drawn in the board. Adiabatic is steeper plot and isothermal comparatively flatter. Now tell me which one will give more work, because area under the PV curve is the work done. Now which one is giving more work? According to this diagram, which one is giving more work? Tell me. Which one is giving more this area under the PV curve? Isothermal. So work done in isothermal more compared to adiabatic. Because in case of isothermal, heat is supplied from by the surrounding. It is collected from the surrounding. But for adiabatic, it is totally whatever heat you have inside the system, you have to use that. So that will be less available. So adiabatic work will be less because heat supply is less. Why? Because heat is not supplied. It is you are whatever work you are getting, that is out of its own internal energy. It is supposed to be less. But in case of isothermal, heat is always collected from the surrounding to keep the temperature constant. So heat is collected from the surrounding. That can be converted to work. Total available heat is more. So work done also will be more. Because Q and W are directly proportional. Okay. What is the first law? Delta E equal to Q minus W. So if Q is more, W must be more because delta E is constant. Think over. Isn't it? Q plus Q equal to delta E plus W. So Q minus W is delta E, first law. Q minus W equal to delta E. Q and W depends on path, but delta E does not depend on path. It is a fixed parameter. So if delta is fixed parameter, Q and W must be proportional. If Q is more, W is more. Understood? So if you supply more heat, more work must be made available. Give more energy, more heat, you get more amount of work. Quite obvious. Otherwise, because energy is conserved, it cannot be created. If you give more energy, you get more work. So here, in case of adiabatic, you are not supplying any heat from the outside, any external agency. It is by conversion of its own internal energy, some amount of heat is converted to work. Whatever is contained in the system, that is getting converted to work. It will be less. So it is matching with our expectation. And in case of Isothermal, temperature remain constant, so heat must be collected from the surrounding. That's why temperature is constant. Expansion work is going on, work done by the system, but the temperature is maintained constant. How possible? Because heat is collected from the surrounding. So as you are collecting heat, that heat must be converted to at least some portion to be converted to work. So you are getting more work. Alright. So what is the work done? Here, area under the PV curve. So adiabatic plot, area under the PV will be less, and isothermal plot, area under the PV is more. So work done is more. So if there is a question, which one is giving more work? Adiabatic or isothermal? Obviously isothermal. Achha. Reversible and irreversible, which one is more work? Reversible. Last year I did numerical derivation. Some of you are present. Next, coming to mathematical formulation of adiabatic work. Mathematical calculation of adiabatic work. Just look at here. So PV equal to nRT initially. Okay, but it is adiabatic, so that's why T not constant. T not constant. Adiabatic I am taking. But PV equal to nRT is always true. Whether adiabatic, isothermal, always PV equal to nRT is true. But T is not constant. So if you do the differentiation, what do you get? PdV plus VdV equal to nRT. T is varying, it is not constant. So you are getting nRT. Next is this relation we are applying. From here, this is PdV plus VdP, right? VdP equal to minus gamma PdV. If you apply this relation over here, we are getting this. And another next line, PdV equal to nR dt by 1 minus gamma, and dt is T2 minus T1. So final relationship is coming this. If you want, I can derive once more, because derivation, if you do practice, you will be more confident. You also do it at your rough notebook. Do the practice. So delta E equal to CV delta T. That you know. So what done? W equal to minus delta E. Because what is the relation? Q equal to delta E plus W. And adiabatic means Q equal to 0. So W equal to minus delta E. CV delta T. So T1 minus T2. Right? Now Cp minus Cv equal to R. And Cp by Cv minus 1 equal to R by Cv. So gamma minus 1 equal to R by Cv. Now here this one, C1 equal to PV equal to nRT. T1 equal to P1 by nR. P1 by nR. So here also I will take nR because there I have taken nR. Otherwise you cannot match. Now Cv by nR. One by gamma minus 1. This is the work done. For the adiabatic process, this is the work done. This is already there in here at this case, but if you want to do practice, do it like that. Do it on your own. Start with the first law. Delta Q equal to delta E plus W. So W equal to minus delta E. And delta E equal to CB delta T. So CB into T1 minus T2, because minus sign was there, so T1 minus T2. And T1 equal to P1 by NR, and this is P1 V1 by NR and P2 V2 by NR. So you take the CB by NR as a parameter, and next in the parenthesis you have P1 V1 minus P2 V2. This CB by NR is gamma minus 1, that I have already separately proved. So just put it there. So P1 V1 minus P2 V2 by gamma minus 1. And ultimately here is also the same thing. Here it is T2 minus T1. That's why it is 1 minus gamma. Okay, this thermochemistry not there in the syllabus, so I skip it here. Carnot cycle also I have removed from the syllabus because it is very big derivation, not that necessary. But one thing we can learn from here, from Carnot cycle. What is Carnot cycle? What is the application? Our heat engine. Can you give one example of heat engine? Yes, heat is getting converted to some other work or some other energy. That is heat engine. Heat engine means heat is getting converted to work. That engine. Huh? Thermal power plant. Achha. Our vehicular, this one, that engine, that is also heat engine, because it is converting heat into that mechanical work, or car is moving. So this is Carnot cycle is actually cyclic path. This is a best example is our vehicular engine, internal combustion engine, where Carnot cycle is applicable, because cycle means what? Cycle means it is coming back to the same point, cyclic process. So Carnot cycle is also a cyclic process, starting from a point and coming back to the same point. That is cyclic process. Now, this Carnot cycle is the basic principle behind that. So, this is a schematic diagram. There is a source kept at a temperature T1, and there is a heat sink at a temperature T2. What is heat sink? Let it be the earth. Earth is heat sink. Whatever heat generated, ultimately it goes to the earth. So heat sink, we can consider earth as the heat sink. And source can be anything where we are producing the heat energy. That is the heat source. This is the heat sink. Whenever heat is passing through from source to sink, if there is a flow of heat, then a portion of the heat can be converted to work. If the heat flow is there, then it is possible. You can convert a portion of the heat into work. If the heat is not flowing, that is not convertible. But if it is flowing, we can convert that into useful work. That is the importance of Carnot cycle. Flowing heat and a portion of the heat flow is converted to work. Now, Q1 amount of heat is coming from the source, and Q2 amount of heat is going to the sink. So how much is the work done? The W, that is Q1 minus Q2. Q1 amount of heat is flowing, Q2 amount of heat is wasted. How much is the work? Q1 minus Q2. That is the basic principle. So how much is the efficiency? Q1 minus Q2 by Q1. That is 1 minus Q2 by Q1. That is the efficiency. That is called heat efficiency. Okay. Heat efficiency I'm trying to make it simpler. So there is a heat source. From the heat source, Q1 amount of heat is going to the heat sink. Here temperature is T1 and here the temperature is T2. Okay. So there is some amount of work in the middle. that is W. So how much is the work done? Q1 minus Q2. And so this is the work done. So what is the efficiency? Efficiency is represented by eta. Heat efficiency, that is W by Q1. How much we got and how much we supplied. That is the ratio is called efficiency. How much energy we are supplying and out of that how much work we are getting. That ratio is called efficiency. So this is our efficiency. So this is Q1 minus Q2 by Q1. Into 100 if you do percent efficiency. Otherwise it is just efficiency. And it is also equal to Q1 minus T2 by Q. That is also the same thing. So whatever here written so many things in a simplified manner I told you. Okay. Q2 amount of heat is going to the sink. Q1 amount of heat is we are originally getting. So difference is Q1 minus Q2. That much of heat is converted to work. So W equal to Q1 minus Q2. But if you want to get the efficiency eta, then Q1 minus Q2 by Q1. That means 1 minus Q2 by Q1. And also it is equal to 1 minus T2 by T1. Because the temperature is T1 and always T1 is that high temperature, T2 is lower temperature, then only the heat flow will occur. So T1 minus T2 by T1, that is equal to 1 minus T2 by T1. Now think over, if T2 is 0, efficiency will be 100%. If Q2 is 0, efficiency will be 100%. But practically Q2 can never be 0 and T2 is very difficult to make 0, because if you make temperature of the sink 0, then it cannot be done naturally, it must be done artificially, and that will need more energy than we get it. There will be huge loss of energy. You have to spend a lot of energy to make the temperature 0, isn't it? So practically efficiency cannot be 100%. That is the another form. That outcome of the Carnot cycle. Most important outcome from the Carnot cycle is that we cannot completely get work done out of energy. Whatever energy we give, complete conversion is not there. A portion of the energy must be spoiled, that is called waste heat, and rest we are getting what? That is the second law statement. There are a few statements of second law, this is one of them. That complete conversion of energy into some other form is not possible. A part of the heat must be converted to, means wasted basically. It can be converted to internal energy. That is our first law is telling that. We are getting some raise of internal energy, rising of internal energy. Internal energy will be increased. Okay. See, these statements of second law, there are so many. One statement I told you. Another statement of second law is this, that perpetual machine is an impossibility. If you start a wheel, after certain time it will stop rotating. You rotate the wheel and just release like that. After some time, or maybe 1 hour, 2 hours, some time or other time, it must stop. This rotation cannot continue till eternity. It must stop sometime. Okay, because perpetual motion is not possible. Another law is there, the total entropy of the universe is always rising. Entropy is enhanced. Okay. Energy is conserved, but not the entropy. What is entropy? It is the chaosness or randomness of the system. Lot of example there. You take a pinch of salt, dissolve into water. The salt was in an order state. It's a crystal lattice. When you dissolve in the water, it's getting scattered inside the ball, this bulk of the liquid. then the entropy is enhanced, increased. Why? Because it was a order state, now become disorder state. When it is scattered, it is disorder. When it is ordered, arranged, then it is order. Ordered, less entropy. Scattered, more entropy. Lot of example. You just blast some explosive, entropy is increased. You scatter some books, entropy is increased. Arrange the books in order, entropy is decreased. Anything scattering is quite natural. If you don't order the books into a room, it will be automatically scattered after some time, because you are taking the book and keeping it here, and you are taking some pen and keeping it here. That way if you do, it will be scattered so easily, but automatically it will not be arranged. Arrangement always you have to perform yourself. Okay, so whatever happening automatically, natural, spontaneous, that is rising the entropy. So this increase in entropy is spontaneous, or any spontaneous process will be associated to increase in entropy. Understood? Entropy. So these are the statements of the second law. Clausius statement, Kelvin statement. Heat does not flow upwards, always from higher to lower, never from lower to higher. Unidirectional flow. Okay, that is one law. That heat will always flow in unidirectional way from high temperature to lower temperature, never from lower to high temperature. No heat engine constructed having unit efficiency. That means 100% efficient engine is not possible. These are the statements of second law. Water always comes down from top to downward, never goes from bottom to top. For that you have to use pump. That means you have to give energy. You not gain energy, you have to lose energy. Here, the water is always coming down. This is waterfalls, fountain, waterfalls. Water is always coming down, never going upward. So heat also will flowing downward, never goes upward automatically. That is our common sense. We know that. But this is in the form of a law. That's it. Now we know because these laws are well established. That's why people know. But earlier days, there is a lot of trial. Why can't we use heat from the surrounding and run our machine? That type of thought was there in the middle era. But now these things are well established. We know that it is not possible. That's why we are not trying. Alchemists, what they did? Tried to convert low price metal into gold. Copper to gold. They tried, na? Why? Because the idea of atom was not there. Concept of atom was not there. So it's also similar. Now this entropy is, this is the change in entropy, delta S, S2 minus S1. This is the absolute entropy. Now it is told that entropy is not measurable, but the change in entropy is measurable. Why? Because always there will be some entropy, whatever may be the temperature. It is not zero. Even very close to 0 Kelvin temperature, there is some movement of molecule. It is not totally stagnant. It is not a fixed one. It is always moving, some sort of vibration is there, rotation is there. So that's why entropy is never zero. So if it is never zero, how do you measure the absolute? You can measure the change, the difference. How much was there earlier, how much is now. The difference you can measure, but not the absolute one. So this is called change in entropy, delta S. This is the another definition. The infinitesimal small quantity ds equal to dqr by t. Reversible heat exchange divided by temperature, dq by t. That is the definition of entropy change. So finite change if you want to get, then the integration symbol is applied, dq by t. Or it can be called q reversible by t. Here q reversible by t. That is entropy change, not the absolute entropy. There is a third law of thermodynamics. Already I have told you, 0th law, first law, second law. There is a third law of thermodynamics. According to third law, in this case law means rules. So according to third law, absolute entropy can be 0 at 0 Kelvin temperature for a perfectly crystalline solid material. Once more, for perfectly crystalline solid material, entropy will be 0 at 0 Kelvin. But for a perfectly crystalline solid only. Write down the statement. All of you write down the statement. Third law of thermodynamics. Absolute entropy of a substance will be 0. Absolute entropy of a substance will be 0 at 0 Kelvin temperature for a perfectly crystalline solid. For a perfectly crystalline solid. Do you understand the meaning of perfectly crystalline solid? Perfectly crystalline solid. So what I told, entropy will be 0 for a substance at 0 Kelvin temperature for a perfectly crystalline solid. The substance should be perfectly crystalline. What is the meaning of perfectly crystalline? There is no imperfection, there is no defect in the crystal lattice. There should not be any defect in the crystal lattice. Then only for that substance at 0 Kelvin temperature, entropy, absolute entropy will be considered 0. That is called third law of thermodynamics. Now what is the importance of this law? You can calculate the absolute entropy of a substance at any other temperature, because at 0 temperature it is 0. So from some other temperature, what is the entropy you are getting? So one value is 0. So other value will be automatically absolute. That way you can get it. But it is only possible for perfectly crystalline solid, not for amorphous materials. And perfectly crystalline solid means there is no lattice defect. And you know there are a lot of lattice defects here and there. Schottky defect, Frenkel defect, there are defects available. So if there is no defect, perfectly crystalline, then only in that case we can measure the absolute entropy with the help of third law of thermodynamics. Now entropy from entropy calculation. Some entropy calculation we will perform now. So how do you do the entropy calculation? Give the heading entropy calculation. You do yourself, then you will be more involved. That is the purpose. If I draw on the board, I will be involved. You will be free and you will be talking. You get involved yourself. Write down the first law of thermodynamics formula. What is the formula? First law of thermodynamics. Write down dq equal to d plus pdv. Right now you remember that or not? First law of thermodynamics, dq equal to d plus pdv. All of you sure? Now divide both sides by t. Dividing both sides by t, what do you get? dq by t equal to d by t plus p by t dv. Are you following me or not? First of all, write down the first law of thermodynamics, dq equal to d plus p dv. Now divide both sides by t. That much you can do, na? Divide both sides by t. So dq by t equal to right hand side, what you get? d by t plus p by t dv. This much is okay? Acha. Now dq by t is what? Tell me. By definition, dq by t equal to ds. So in the next line you write ds equal to next line you write ds equal to cv dt by t. cv dt by t plus what you have got there? P by t, na? Write it r by v dv. R by v dv. Now divide, just apply the integration symbol both side. Apply the integration symbol both side. Okay, I am doing it. Don't just copy. Try to follow every step. Don't copy only. That's why I am not writing. Otherwise, you will just copy without your mind. That is meaningless. Apply your mind and then copy. So, what I told, dq equal to d plus pdv. So, by t both sides. So, ds equal to cv dt by t plus r by dv by d. Integration symbol applied. State 1 to state 2. CVLN d2 upon d1 plus r ln d2 upon d1. Is it alright? This one is okay? CVLN t2 upon t1 plus r ln v2 upon v1. Next step, replace t2 by t1 by p2 v2 by p1 v1. Replace t2 by t1 by a parameter p2 v2 by p1 v1. That you know, p1 v1 by t1 equal to p2 v2 by t2. Why can't you replace yourself? Do it. t2 by t1 replace by p2 v2 by p1 v1. And then next step will be what? CVLN t2 by t1 will be replaced as p2 v2 by p1 v1, right? So then CVLN p2 by p1 plus CVLN t2 by v2 by v1 plus RLN v2 by v1. Then CVLN v2 by v1 plus RLN v2 by v1, you can write CPLN v2 by v1. Yes? Isn't it? Can do that. Next, apply different conditions. Isothermal. So from this equation, if it is isothermal, what do you get from this equation? T2 by T1 equal to ln T2 by T1 will be equal to 0 or not? Isothermal means temperature constant. So T1 equal to T2. So this part will vanish or not? If I take isothermal, this will vanish or not? So what you get? RLN V2 upon V1 only, and V2 upon V1 equal to P1 upon P2. Why? Because V2 by V1 equal to P1 upon P2. Okay. Because T constant, isothermal. So this is for isothermal. Similarly, you can find out isobaric and isochoric process. Similarly, you can find out isobaric and isochoric process. Isothermal. Isothermal কি? One part vanish হয়ে যাচ্ছে না? Bracket লিখে দিলাম isothermal. So one part is getting vanished, other part will be there. এটা বাদ চলে যাচ্ছে। এটা 0 হয়ে যাবে for isothermal. That's why. Acha, what about the other one? Other equation, you have got another equation, no? By replacing the T2 by T1 equal to P2 V2 by P1 V1, you have got another equation. There you apply P1 equal to P2. Isobaric, apply P1 equal to P2. One part will vanish, other part will combine and just keep it. CPLN, what you are getting there? CPLN V2 by V1. So all these three relations and make it isochoric, V constant. So all these different conditions, you keep it. These are called different entropy relationship. Different forms of entropy relations. So isothermal, isobaric, isochoric conditions, entropy relationship, entropy calculations. Now one thing here to learn, that You know, energy is conserved, but not the entropy. Any process happen, delta S of the system plus delta S of the surrounding not equal to 0, greater than 0. That is the difference between entropy and heat. Heat is conserved because it is energy, it is conserved, but entropy is not energy, it is not conserved. Entropy is always rising, entropy of the universe is always increasing, though the temperature may remain constant, but entropy can rise. There is no direct relationship with the temperature. Okay. Indirectly related, because dq by t equal to ds, so t is there, but t and dq, they will be proportional. There should be some relationship, proportionality. Heat cannot be conveyed to work without leaving permanent change either in system involved or their surrounding. There will be some permanent change. It is not reversible always. Different statements of the second law of thermodynamics. All the laws I have told you earlier. This any spontaneous process, entropy is always rising. It is not constant, it is always rising. Normally we say this is constant, that is conserved. Here it is not conserved, rather it is always rising. Any spontaneous process, entropy will be rising. Okay? Heat always will flow from higher temperature to a lower temperature of a body. 100% efficiency is never possible. Build a perfectly efficient means 100% efficiency. It is impossible to build a perfectly efficient steam engine or heat engine. Okay. No steam engine can be more efficient than reversible steam engine. It is impossible to build a perpetual motion machine. All these are second law statements. Entropy change calculation already I have shown you in the board. Now, physical significance of entropy also, as we discussed something like a pinch of salt or pinch of sugar, if you dissolve in the water, entropy is rising because the molecules are getting scattered. Earlier it was ordered, now it is getting disordered, and accordingly entropy is rising. Now, there is another form for the physical significance. There is a formula that is called S equal to K ln W. That is a relationship. Physical significance of entropy. There is a mathematical relationship S equal to K ln W. What is S? Entropy, absolute entropy. K, Boltzmann constant. Ln you know log, and W is thermodynamic probability. And this thermodynamic probability is what? It is related to degrees of freedom of the molecules. Degrees of freedom of the molecules. Degrees of freedom of the molecules. S equal to, write down, physical significance of entropy. Physical significance of entropy. Capital S, नीचे देखो, capital S equal to small k ln capital W. Small k ln capital W. अच्छा, now S is absolute entropy. K is Boltzmann constant. R by N0. Boltzmann constant, you understand? That is R by N0. What is R? Absolute gas constant, R. By N0, Avogadro number. So that R by N0 is called Boltzmann constant. And what is capital W? That is thermodynamic probability. That is called thermodynamic probability. Okay. So there are some statements written, entropy, this randomness or chaosness. It is also called the disorderness of the system. That is the entropy. Physically, what you understand about entropy? It is the chaosness, randomness, disorderness of the system. The more the disorder state, more will be entropy. And this formula, as I was telling, S equal to K L W, this is the thing. And what is W particularly? This is very important. K, you understand, K is very simple. K is what? R by N0. R means absolute gas constant R. And what is N0? Avogadro number. So R by N0 is this small k, that is Boltzmann constant. And what is capital W? Thermodynamic probability related to degrees of freedom of the molecules. Degrees of freedom of the molecule. Do you understand the term? Degrees of freedom of the molecules. How many ways the molecule can move? Number of ways of movement. Number of ways of movement. This is a bit detailed, so I skip it. Calculation I have done already on the board, so I skip it here. Next function I think it is called free energy and equilibrium. What is free energy? It is called Gibbs free energy. Gibbs free energy, but this particular term is called Gibbs free energy. This free energy, why this term free energy? This is free to utilize. We can say it is the utilizable form of energy. And by definition, write down free energy. Free energy. Below that you write G equal to capital G. Capital G equal to capital H minus Ts. All capital. G equal to H minus Ts. All of you write G equal to H minus Ts. This G is called Gibbs free energy. Equal to H minus Ts. What is H? Enthalpy. And T, temperature. S, entropy. All are having their own specific significance. Always a symbol carries its own specific significance. So what is the formula here? G equal to H minus Ts. Now at a constant temperature, H del T will be 0. Del G equal to del H minus T del S. Del G equal to del H minus T del S. Now, this particular formula is very, very important. Del G equal to del H minus T del S, because the reaction or any process will occur or is not feasible. Whether the feasibility there or not, whether it is possible or not, we can understand from this equation. Okay? Now write down different conditions when the process can actually occur or will not occur. Number one condition, del H is negative and large. Del H is negative and large, and del S positive but small. That is condition number one. It is a condition. I am applying a condition. Del H is negative and large, whereas del S is positive and small. Del S is positive, not small. Cancel the small. And this condition, if you apply, always del G will be negative or not. Just think, if del H is negative and large and del S is positive, what about that overall del G? Negative, and it will be spontaneous. If del G is negative and del S is positive, del G will be always negative, so it is spontaneous. And so this is the condition for spontaneity. Spontaneity, what is the meaning of spontaneous? It will happen by itself. It will happen by itself. That is called spontaneous. So spontaneity condition, this is one more one. Number 2 condition, del S is negative and large, del S is negative and small. Then also it will be spontaneous. Second point, del G is negative, del H is negative and large, and del S is negative but small. Then also del G negative. So in this condition also del G negative. Another third condition, del G is del S equal to positive but small, and del S is positive and large. Del H is positive and small. Third condition. Okay, del H is positive and small, but del S is positive and large. Then also it will be spontaneous. That means whatever may be the way, if del G is negative, it will be spontaneous. Ultimate conclusion is this: whatever may be the way, if del G is negative, it is spontaneous. The process will be spontaneous. So in general you can say this is the conditions for spontaneity. Del G negative. It is called necessary and sufficient condition for spontaneity. Del G must be negative. For condition of spontaneity, what condition? Del G must be negative. That is the only one condition. Then the process will be spontaneous. And if del G is not negative, it is not spontaneous. And if del G equal to 0, equilibrium. Third condition, del H is positive and small, and del S is positive and large. Then also it is negative now overall. Overall it will be negative. That means in a different manner, I just cooked it in different manner to present you such a way that different way, whatever may be the way, del G we are making negative. So for that, whatever you do, it is ultimately becoming spontaneous. 3 different ways I applied, different conditions to make you understand whatever may be the way, if del G is negative, it will be spontaneous. And normally, there is another thing, normally if del S is large and positive, process is spontaneous, but there is not necessary condition. It is a condition, but not necessary condition. Del S means entropy rise. If the entropy rise is very large, then usually it is spontaneous, usually, but not necessary or sufficient condition. And what is the necessary sufficient condition? Del G must be negative. And if del G equal to 0, equilibrium is said to be exist. There will be equilibrium. In the equilibrium status, del G will be 0, equal to 0. So in general, del G less than equal to 0 is called feasibility condition. Del G less than equal to 0 is called feasibility condition. You have written, now I write. Del G equal to del H minus T del S. Number 1 condition, del H negative, del S positive. Number 1 condition. Number 2 condition, del H negative and large, and del S negative small. And number 3 condition, del H positive small, and del S positive large. And del G less than equal to 0, it is called feasibility condition. Less than equal to 0 is feasibility condition. Equal to 0 is for equilibrium, and less than 0 spontaneous. Combine the two, it is called feasibility condition. Whether it can happen or cannot happen. Then based on these two, either equal to 0 or less than 0. So this particular topic I end up here for today.